Hello friends, how are you all today? Have you ever wondered what are random variables and how they can be used in engineering? It's coming up right now. I'm Prashant from Dharini Academy of Technical Education, Bengaluru. We'll be discussing about random variables now.
Let's solve another problem based on the similar concept. Okay, if a random variable x takes values 1, 2, 3, and 4 such that two times the probability that capital X takes a value 1 will be equal to 3 times the probability that the same variable takes a value 2. This is also equal to 4 times the probability that x takes a value equal to 3 equal to 5 times probability that x takes a value equal to 4. So this is the condition. Now the question here is that find the probability distribution. Find the probability distribution PDF and CDF. Right, so we need to find what is the value, what is the probability that it takes a value equal to 1. So individually we are supposed to find out these values. How much is probability that it takes value 1 is how much, this is how much. Individually we need to find, and also we need that gives us PDF. Okay, yes. Next we will go to the CDF. We just have to accumulate them to get the CDF part. Alright, so let's do the first part now. So let's say that uh, the probability that it takes a value 1, 2, 3, 4, we'll assign some notations for them so that it becomes easy for us to understand. Okay, so let's call it, let the probability that x takes a value 1 equal to say p1. So second case, the probability that x takes a value equal to 2, we'll call it as p2. And let's say the p that x takes a value, okay, 3 equals to p3. And let us say that it takes a value 4 equals to x equal to 4 equals to p4. Right, we know a few things about this from the given data. One thing is directly written from the basic concepts of the probability, that since everything p1, p2, p3, p4 are related to a random variable and they are the probabilities, right? We know something. We know that can I write p1 plus p2 equals to 1, right? That's correct. First one is this. And the second thing they have given over there, that 2 times p1 equal to 3 times p2. correct? So I want to substitute for P2, P3, P4 in terms of P1. That's my idea. So what I do, I'll first find out what is the relationship between P2, P3 and P4 with respect to P1. So they mention that 2 times P1 equal to 3 times P2, correct? This is also equal to 4 times P3 equal to 5 times P4, correct? From this, now we can write P2 is equal to, I want to replace P2 in terms of P1, so that is 2/3 of P1, correct? This also implies that the P3 is equal to 2 by 4, that is half P1, okay? Very similarly, you can write P4 can be replaced as 2/5 of P1. I'm writing them, this equation I'm writing by comparing these two. Yes, so I compare 2P1 equal to 4P3 and I write this. P3 is equal to half of that, half of the P1. And the final one I'm writing comparing these two to get this. Alright, now I got the values, so I can directly substitute. Therefore, P1 plus 2/3 of P1 plus half P1 plus 2/5 of P1 equals to 1, right? Now I just have to find out what is P1. Yes, 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 yes. You can take out P1, right? Yeah, yeah, no problem. Fraction is also fine. Anything is fine. No, no problem. P1 equal to half 30 by 77. That is, it's P1. Okay. Okay. Now, once again, I'll just verify. What I have here is 15 by 61. Just check. Can you check that one? 1 plus. Okay. I'll just do that. Okay. No, no, that's right. What you got is right. Please tell me the value. 15 by Okay, what's the answer you are getting? No, the one which I mentioned is for different problem, not this one. Sorry about that. Ah, no problem. 30577. Fine. Now what we do, we'll find out the other values as well. Okay, so P2 is equal to 2 by 3 of this number, that is 30 by 77. This cancels with this as 10. So this is 20 by 77. So P3 is equal to 1 by 2 into 10 by, not 10, it's 30 by 77, 50 by 77. So we can find out P4 equal to 2 by 5 times 30 by 77. This cancels with 6, so this is 12 by 77. Okay, now the what we are supposed to write is the PDF, right? Uh, PDF is nothing but I just have to write what is P of X. And the CDF you are supposed to write this is small f of x, which is nothing but the summation part. Summation I is equal to 1 to a given value x, right? This is P of x. So just to write that, we'll write a let's write a table. Okay. Okay, we need the first column is just to say what we are writing. Then we have four values, so we need four columns for that. Okay, this is all right. Now uh, so here we are writing the x taking a value xi. So this xi value should be 1, 2, 3, 4. The capital X takes these four values as per the question. Then we are writing what is the probability P of x. This is what we found just now. And then below that I am going to write the f of x. So let's just fill up. The P1 is 30 by 77. 30 by 77. P2 is 20 by 77. Okay. P3 is 15 over 77. And the last one is 12 over 77. Okay, so when we write f of x, we just have to add all the p of x before that value. So before and equal to that value. So here no previous value, only the present value exists. This becomes equal to 30 by 77. But when I write the next one, that is what I write here is this plus the previous one. So this is 30 plus 20, right? We have 51, 27. Then to this 50, I'm supposed to add 15. So 65 over 77, right? So last one is nothing but you are adding all the 4, so it becomes 1. Okay, 77 by 77. So this is how we calculate the PDF and CDF of any required function. Right. So next, we'll directly move on to the distributions. Okay. The first distribution which we are going to discuss is yeah, binomial. We'll start from the easiest one. Binomial distribution. Okay. Now, let us say there is an event. The event has two possible results. Okay. In that event, let's say we had two results, right? The first result is what I'm going to call as success, and the second result, let's call it as a failure, in the sense yes or no type, right? Like head or tail. Today it will rain, it will not rain, like that. So experiment has some results, and that result is of possibility of getting a result in two ways. Okay, so directly I'll write if P is okay, we'll write a probability of success. Probability of success. So now actually I can directly write the probability of failure, which is 1 minus P, correct? Probability of success, and Q, which is equal to 1 minus P, right, is the probability of failure. Then let's say this is for one event, right? Event happening once. Now what I do, I repeat this, the whole experiment I repeat n times. Okay, and my intention is that, okay, out of n trials, how many times you get a success is what I want to find. Okay, right? So in the sense, when you throw a coin, I know that head is 50%, tail is 50%, right? So P is 0.5, Q is also 0.5. But when you throw the coin, right, 100 times, probability that you get 20 heads. So that trials is 100, success rate is 20. This is what I'm trying to find out. Okay, so then X success out of n trials, okay, has the probability, right, that is P of X. P of X is equal to, see, this is the formula given by the binomial distribution, NCX P to the power X, and this is Q to the power n minus X. Okay, Q is 1 minus P. I can directly rewrite this as, so this is NCX P to the X 1 minus p to the n minus x. This is the p of x. Okay, all right. Now, if you want to represent the binomial distribution, right, and if you want to apply this somewhere, we need to have its mean and variance. Okay, so for binomial distribution, the mean, its mu, is given by the n times p. N is the number of times you repeat. Okay, p is the value of the probability of success. Okay, and the variance V is denoted as NPQ, and if you remember, the standard deviation sigma is nothing but root V. That's why it is root of NPQ. So this is one standard discrete random variable. Okay, discrete distribution. Right, very similar to this. We'll see two discrete first, then we'll solve some problems. All right, so I'll go to the next one now itself. That is Poisson's distribution. All right, so here the probability of x is given by, so it means the same thing. Whenever the n in the binomial reaches very large value like infinity, when the n tends to infinity in binomial, this becomes a Poisson's. Okay, that's the basic difference. Anyway, we'll write. So the p of x is given by, p of x is equal to, this is m to the power x e to the minus m whole divided by the x factorial. This is called as the probability, right? So there is a constant value that is dependent on some variable, that is m. M is called as the constant of Poisson's distribution. Okay, so this m is a constant. Okay, all right. Now let's write its mean and variance. Okay, so here the mean m is the mu. It's the reverse. Sorry, I'll write in the reverse way. Mean is given by m itself, the constant which we call, right, that itself is the mean. Mu is equal to m. Okay, here the variance v is also m, so sigma becomes root m. Alright, now let's solve some questions based on these two distributions. Uh, First problem, right? A coin is tossed 4 times. Find the probability of getting, let's have few sub questions here. This is exactly one head. Part B of the question, maximum of three heads. Okay, and part C of the question, at least two heads. What we want to find. Okay, so by just looking at this question, see, probably whenever we get questions based on the distributions, normally distributions name will not be mentioned, right? We need to identify, right? So I understand, I just look at the question, I understand that, okay, you are tossing a coin. Tossing a coin means what are the possibilities? You can have head or tail. Two results are possible. This experiment is repeated four times, right? So it is n repetitions, and the question is exactly one head. So x value is given, success is 1. Next, success is 3. Next, success is 2. So x value is given. So n and x are given with p and q. P and q is equal. We just have to assume, right? We cannot, they are not giving the values. So what we, yeah. So for a coin, it's a very standard thing, right? So always you assume whenever the probabilities are not given, you have to make them equal. Okay, so we'll write, if obtaining a head is, that is p is equal to 1 by 2, so q becomes equal to, that is 1 minus p, that is also 1 by 2. Okay, and we see that this whole experiment is repeated four times. X varies from the problem to problem, in the sense A, B, C, three subparts we have. Each one has a different X. So X I'm not writing, but how many times it is repeated, I can write. So exactly one head means what? Probability that the X is equal to 1. Correct? Anyway, before that, so it uses binomial, I understood that. So let's write the binomial distribution for this. Binomial distribution p of x is equal to, I know that this is nc x. So p to the power x, that is half to the x, 1 minus p to the power n minus x, so that should be once again half to the n minus x. This is the probability. PDF is given by this. Fine. Now let's answer the questions one by one. So it says that at least one head means what? The probability that x takes a value equal to 1. What is the chance that x is exactly equal to 1 is the question. So just write, this is 4c1, okay, into, just fill the value x equal to 1 in the equation. N value is 4 already known. So this is 1 by 2 to the power 4 minus 1. So this is equal to 3. I just have to substitute the values. And when you substitute, I think we get 1 by 2, 4. 4 will cancel with two of them. Okay, this looks like 1 by 4. Okay. All right. Now, part B says that maximum of three heads. In the sense, you can get one head, or you can get no head, right? That's also a possibility. You can get you are throwing the coin four times. Now all the four times you are getting a tail. That's also one of the case. No head, one head, two heads, or three heads is what is the question. Maximum of three includes all the four possibilities. Yeah, here we are supposed to do that. So x is less than or equal to 3 is what they are asking. It actually indicates p of x being equal to 0 plus the probability x being equal to 1 plus the probability x being equal to 2, right, plus the probability x being equal to 3. So x equal to 0, and so p of x is already given, correct? Already we have represented that over here, right? In this, substitute x values four times, correct? X equal to 0, x equal to 1, x equal to 2, x equal to 3, and then we will be able to write this. So this is equal to, I'll write first x equal to 0, so that is 4c0 into half to the 0 into half to the 4 plus 4c1 half to the 1 half to the 3 plus 4c2 half to the 2 half to the 2, 4c3 half to the 3 half to the 1. Yes, yes, yes. One by four, yes. Okay, all right. 15 by 16, right? Okay, so this comes to be 15 by 16. Very similar to this, we need to answer the next part, that is part C, at least two. At least two heads, correct? So at least two heads means two or more than two. So this is P of x greater than or equal to 2, correct? So which means probability that x can become equal to 2 plus probability x is equal to 3 plus the probability that x is equal to 4. All the four can be heads, right? So we can substitute this same from the previous one. That is, okay, I'll write the values. So that is 4c2 half power 2 plus 4c3 half to the 3 and half to the 1 plus 4c4 half to the 4 half to the 0. Final answer you are getting. Yeah, okay. This is 11 by 16. Then let's go to another question. All right. In a company, the probability of manufacturing a defective item is, this is 1 by 25. 180 per day. What is the probability of RA? Three items are defective. Okay. Part B. At least defective. See? None of them are defective. So here we can see that the experiment here is to find out a produced item, manufactured item is defective or not. So being defective is what you are looking for. So it's mentioned that probability of that, we give it as P, is 1 by 25. So what should be the other way? That is, probability of not being defective should be 1 minus 1 by 25. So that is 24 over 25. So, and they are mentioning that this experiment is repeated 180 times. So n is equal to 180. No need to go for poisons. Poisons is like when you go for very big numbers, like it's going to till infinity, in the sense 1 lakh, 2 lakh, like that. Okay. N is too large means you can go for poisons. Smaller values, less than 1000, 2000, or even maybe sometimes 10,000 also we go for this itself. But when n reaches larger values like 10,000 and all, even poisons gives the approximately same answer. So doesn't matter what you use when n is large. Okay, but for small n you should go for binomial. So this is binomial. We'll write p of x is equal to ncx. So this is 180 cx p to the x. So p is equal to 1 over 25 to the x into 24 by 25. This is 180 minus x is your equation. First part, exactly 3 items are defective. So what they are asking is p of x equal to 3. That means 180 c3 1 over 25 to the 3, 24 by 25 to the power 180 minus 3, right? 177. Okay, next part B. At least 5 defective items. At least 5 means, right? More than 5. 5 or more than 5, correct? Correct. So x greater than or equal to 5. So this means, right, it has to be 5, 6, 7, 8, up to 180. So making that calculation is difficult. You can do the otherwise. Correct. Subtract from 1. 1 minus. Okay, first let me write the notation for this. This is 1 minus probability that x is less than 5. Less than 5 or less than or equal to 4. Right? Anything is fine. So that means I'm supposed to write this is 1 minus p of x equal to 0 minus p of x equal to 1 minus p of x equal to 2 minus p of x equal to 3 and p of x equal to 4. 180. So x, okay, I'm supposed to subtract from 1, my mistake. So first we'll write 1 minus, this is 1 minus 180, this is 180 c 0, 1 by 25 to the 0, 24 by 25 to the 180 minus 180 c1, 1 by 25 to the 1 into 24 by 25 to the 179 minus 180 c2, 1 by 25 to the 2, 24 by 25 to the 178 minus 180 c3, 1 by 25 to the 3, 24 by 25 to the 177 minus 180 c4, 1 by 25 to the 4, 24 by 25 to the 176. Yeah, sure. Please take your time. Okay, 0.849. And we have a part C. It says that none of the items are defective. Okay, so we have the answer for that. Q 6.43 into 10 to the minus 4. Okay, okay, right. It's a straightforward question. Then when 20 items are manufactured by a company, two are found defective. Okay, now if 1000 samples manufactured, find the probability that at least 3 are defective. So we want to find out that out of 1000 samples, right, what is the probability that 3 are defective? No, I use a probability directly, right? If you directly use same as probability. So P is equal to how much? P is 2 by 20. So that is 1 by 10. No, 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 no. You got a probability. You use it for your experiment. Experiment is done 1000 times. So Q is, yeah. When a company produces 20 items, 2 are found defective. Okay. Now if you produce 1000, what chance you have that at least 3 of them are defective? N is 1000. Yeah, binomial we can use. The question asked here is P of x at least 3. So greater than or equal to 3. So 3 means it will go till how much? It will go till 1000. So that is difficult. So what we do, we subtract from 1 minus P of x equal to 0 minus P of x equal to 1 minus P of x equal to 2. 1 minus 1000 C0, 1 by 10 0, 9 by 10 to the 1000 minus 1000 C1, 1 by 10 to the 1, 9 by 10 to the 999. 1000 C2, 1 by 10 to the 2, 9 by 10 to the 998. Hmm. It's a one. Okay, this part is very small, so you are getting one, right? Yeah, you will. It means it's a definite event. Like it says that the value is one, which indicates that you will definitely get. What is the chance that you get at least three defective? You will definitely get three defective items. Yes, the chance you have a chance of getting. Uh, it's 100% chance that there will be at least three defective items. Okay, perfect. All right. So we finished the problems based on the first type of distribution, that is binomial distribution, in today's class. In the next class, we'll directly start solving the problems based on Poissons, and then we'll proceed further. All right. Okay then. See you in the next class.
That's all for the day. Feel free to contact if you have any doubts related to any topics in engineering. We can also help you in solving your assignments, projects, and many more. Thanks for watching. Good day.